Hello everyone. So the question I wish to answer, but I do not believe I will, is how do you see? And I'd like to tell you I hacked my brain and now I've extracted the source code and I'll tell you all of its secrets. And I don't think that's going to happen ever. But I do believe I can give you words that are useful and show you all the effort I put into understanding how I see. To make a system for my eyes that allows me to see something that I can't see right now. So let's start off with a little experiment. Now I'm going to show you these dots here. And what are they? It's a little hard to see even for me. And so I'll add these lines here, and now it should be pretty obvious. It's a 5. Now, why can you see that? They're two different things. I mean, they're pretty close, but they're pretty different. So that's the question that I wish to explore is, how can I see something before it's completely revealed like I did in that? What do I want to see? I want to see the future. I want to see what's going to happen in the future. Just like that one Alpha's character from Alphas, I think. I want to see the future, similar to the TV show Alphas, where he could kind of see everything going on. But I'm going to first understand the current position of a body, and I'm really going to work on replicating exactly, compressing the data in such a way that I can replicate it easily as well as record it easily. So what makes me uniquely qualified to do this? Well, I have a vocabulary, and this means nothing much really. I studied some machine learning. I'm definitely going to use some of the words from there. I've studied computer graphics, and I'm definitely going to use some words from there. And then I've also spent some time training my eyes. And this is something that's dumb, I feel like. It's almost useless. Like, for example, the saccadic suppression of your eyes when you move rapidly is something that I've trained to see a tiny bit more. I can't see while it's moving, but I can see car wheels and the rims and see the spokes while they're turning, using saccadic suppression as a means of seeing while I'm not getting anything from the eye. It sounds dumb, but I think it's a tiny bit useful. Now, I'm going to introduce the idea of a filter. And here we have a Google homepage, and I'm used to using the internet and browser. So this is how I kind of see the page. I mean, there's other things like the URL address, but forward to backward search, that's really all I need. That is a highly optimized filter. As you can see, I'm going to show you some unoptimized filters. So we're just going to count how many balls there are. And here I have 2 filters that should help me reduce the cost. So on the left side, we have a vertical lined filter. And as you can count, each one of these has a certain amount of dots in them. So, we got 3 with 1. And we can assume the cost to count 2 dots in the same box is going to be more. Okay? So 3 boxes of 1, 1 box of 2, total of 5. Now on the right here, we have a more unfit counting filter. So we have 3 boxes of 1, 1 box of 2, and 1 box of 4 for a total of 9. And this is where I think if people aren't exposed to the same things, they're going to have trouble seeing. For example, if you're teaching somebody who hasn't used computers, that using the Google homepage is going to be very disorienting or something like that. I mean, it's very simple, don't get me wrong, but they may click something wrong to find something. Now we're going to talk about the eyes and how they send data to your brain. So there's blurry and partial updates. This has to do more with when things go fast, you can't see them, like what I was talking about, the wheels and how they blur together. And speaking on my next point, the partial updates are kind of with a focus. You're going to focus on that one part, and maybe the other stuff is kind of blurry in the background, but you see that one part really well. Here's some objects. I'm not sure if this is 100% the eyes, but you know, objects. I mean, we've all seen the scary man when we've woken up in the middle of the night and there's this shadow that looks like a person, and as long as it doesn't move, we're not really scared. Now, what happens after your brain receives the info? This is where I think we can inject data and try to get different results. But that does come with some costs. Possible hallucination. In this sense, it's more of the AI hallucinations where we'll get wrong data. And also, I'm not even sure this is a function we can actually do. What I'm talking about is I look at an image or look at something, and then I try to change it and see what comes out. You know, it's kind of like that 5 from before, where I try to imagine a 5, and then I just start taking out parts, and I try to run that through like I've seen it through my eyes, and see if I think that would be a 5. Like, and try to just cut out all that middle stuff. And yeah, I could be lying to myself. I hope I'm not. But also, I can't really know. But it's fun. And then here's a machine learning word, inferencing. This is running it through the model. So inference time would be how long does it take for your model to work through an image. And I think this also has to do with some flow state stuff, where you're taking the amount of information you can actually process and you're slowing down your eyes a little bit. Because let me tell you about something dumb I do. I throw a ball at a wall and I try to hit myself, and then once I've let go of the ball, I try to remain calm and do a casual dodge. Now, this is not smart, so don't do this at home. But when I feel the most capable of this, I feel like I'm going at like 5 frames per second from my eyes. I don't feel like I'm going at this, you know, regular 30 frames per second. Oh, everything looks regular. But also I feel more in control. So it's kind of this weird thing. You know, you expect it to be like, oh yeah, I can see at 240 frames per second, which would be cool, but it doesn't feel that I can actually see. This could be different for me than it could be for you. And that's what I don't know. Here's how I want to see differently. So first, I'm going to build features. That's a machine learning word. That just means I'm going to find things and compare them. So what I want to do is I want to see you and be able to replicate whatever pose you are in right now. In the simplest way, I want to build a set that's going to do that. So I think phase one is, really simple. It's going to be 4 items, each with a degrees, and it's going to be knees and elbows, trying to figure out what degree is your knees and elbows at. And this would allow me, I think, to get 90% of the way there. Then we have your wrists and ankles. This wouldn't be a big bump, but this would add another dimension because the wrists and ankles each have 1 extra degree of movement. And then this would get probably 90% of the way there. We have the spine, shoulder, and feet, and it's just these each have multiple dimensions that it can move along. And then just, this probably be the final phase, hands and feet. And these would each be extremely complicated. So for phase one, it'd be pretty simple. It'd be a rank 1 with a size of 4. And that means it's going to be a 1-dimensional array with 4 things in it. Now, for phase 2, I could make it a 2-dimensional, a second rank, where it has 2 dimensions for the extra ones for the wrist and ankle, or I could make it a first rank where it just has 12 options. I'm not sure it really matters, but it's an idea. It would be less space, I think, for the 1-dimensional one in this case, because it's not a lot of redundant. So yeah, the whole point of this is just get some sick dodges. I hope you enjoyed and got something out of this, and thank you for watching.